Okay, so I figured I would make a video just to talk you through calculus and differentiation. I know some of you have done it already, some of you haven't covered it at all, so this will either be a recap for you or everything here will be new and hopefully we can make sense of it. A lot easier to explain this obviously using a video than trying to type it all out. I have notes that I'll put up in the Google Classroom as well. So first things first, what is differentiation? So essentially all that differentiation is it deals with the rate of change of a function. Now we know that a function has inputs and outputs, and typically we can graph them. So here in front of us we have a graph of a linear function. Linear obviously because it creates a line and there's no change to the rate of change, if that makes any sense. So the rate of change of this function is simply the slope of the line. We have our formula for that. It's y2 minus y1 divided by x2 minus x1. And if we found the slope of this line and it's going to be positive, say we said that the slope, or m, is equal to 2. Well, then the slope here is 2. The slope here is also 2, and it's 2 here as well. Anywhere along this line, in front of us obviously we have a line segment, but anywhere along the line our slope will be 2. It's not going to change because our line is increasing at the exact same rate for the duration of its existence. Okay, but things get a little bit more difficult when we start to consider curves because, well, they're changing all the time. It's quite steep and positive here, and then it levels off and it becomes steep and negative, and we have those changes, and we typically see them in our quadratic, and in front of us here we have a cubic equation. So we can't get one number that represents the rate of change for a curve like we did with our line. We saw with that last line that the slope of that line was 2 for the duration of its existence. However, on this curve our slope is constantly changing. As we said, it's positive up along here, it's positive, slope is increasing, and then it becomes negative and negative all the way down here until again we go back to a positive. So how do we deal with this? So the way we deal with this is using calculus or differentiation, and it's a way to address these rates of changes, and we apply some very particular rules to our function which represents the curve. So here we have this function that represents the curve drawn in front of us, and the function is x cubed plus 2x squared plus 8x minus 4, and we can see it's clearly a cubic equation because it has 3 roots. Power of 3, it has 3 roots. Roots are where it is grounded on the x-axis. So what we can do here, and the language might get a little confusing, but I'll try to work through it. What we can do is we're trying to see what the rate of change at any given point is. We can't evaluate, as I said, the rate of change for the whole thing, but we could say, well, what's its rate of change here at this exact point? Or what is the rate of change of the tangent at that point? Because we know we can find the rate of change of a straight line. So if we were to draw a straight line that was identical to that exact second on the curve, what would the number to represent that rate of change be? Okay, so we have our rules of calculus given to us on page 25 of our log tables, and particularly these guys are going to be what help us the most here, and primarily it's going to be that top one that is going to be our most used rule when it comes to calculus or differentiation, same thing. Alright, so let's see what we can do with this guy. If we were to differentiate this, we represent that as f prime x, and what that means is we're differentiating this function in terms of x because it's written in x. X is the variable here, the unknown. Okay, so our rules there on page 25, if you have a look at those as we go through this, the first rule says you bring down the power and reduce the power by 1, and we're going to go bit by bit here. So x cubed, we bring down the power, which is 3, and it becomes 3x, and then reduce the power by 1. 3 take 1 is 2, so that's 3x squared. Okay, 2x squared, well that becomes 4x to the power 1 because we brought down our 2. 2 by 2 is 4, and reduce our squared by 1. Our squared, 2 take 1 is 1. And then finally we have our 8x, and that just becomes 8 because the power there was 1, and we would have reduced it by 1, and anything to the power of 0 is just 1. Okay, so that would be 8 times 1. And then finally we have our minus 4. Now we're differentiating with respect to our variable here being x, so we don't need to bring that minus 4 into the next equation because it's just not necessary. We're differentiating with respect to x, it doesn't have an x, so we don't need it to continue on with this question. And what we found here are 3x squared plus 4x plus 8. What this is it represents the rate of change at an instant on this curve. So this function here, it's a new function, it's f prime x, will represent the rate of change at any given moment on that curve in front of us. All right, and particularly with these questions, what we're going to be asked is to find the coordinates of the maximum or minimum point. And let's have a look at how we might be able to identify those. We can see with this curve that, you know, it's positive, 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 positive in terms of its rate of change or its slope. And then it becomes negative, negative, negative. If we think about numbers, if we're to go from a positive number to a negative number, say we went 3, 2, 1, 0, minus 1, minus 2. We have to cross 0 in between those. We can't just go from minus 1 to 1 or vice versa. So what that would hopefully tell us is that at a local maximum or a local minimum, the slope is 0. It's not changing at that exact instant, okay? It's not getting any higher, but it also hasn't started to get lower yet in terms of the height of the curve. And if we were to find, you know, the slope of the tangent, we would see that the tangent is parallel to the x-axis, and any line that's parallel to the x-axis has a slope of 0. So armed with that information that at a maximum and minimum point, the slope is 0, let's see if maybe we could figure out the x coordinates of the maximum or minimum value. Okay, so as part of our last question or our last calculation, we had that f prime x is equal to 3x squared plus 4x plus 8. That's what we found. Okay, that is the derivative that describes the rate of change, and we know that at a maximum or minimum point, 3x squared plus 4x plus 8, the rate of change, will equal 0. We now have a quadratic equation that is equal to 0. All right, this can be solved either by straight up factorizing or using our minus b formula. All right, so I didn't really want to do the whole minus b formula there or factorizing because I think we're all pretty familiar with that at this stage. And it's just going to slow the process here. I did happen to make one change just to our equation. I changed the positive 8 to a negative 8. Now the only reason behind that was because I wanted to make calculations a bit easier on myself. So I've also changed it here in the original expression. The original expression has changed to x cubed plus 2x squared minus 8x minus 4, and that change is carried through the whole way just to make life easier for myself, because otherwise it just would have turned out as an imaginary number, and that's not fun. So what I found was x is equal to 1.097 and x is equal to minus 2.431. And what do they mean? They mean that my maximum point here, this guy, its x coordinate is minus 2.431, minus 2.431. And it also means that this guy here, his x coordinate is equal to 1.097. Now I have rounded those numbers. They did have quite a large quantity of decimal values, but I've just rounded it to 3 decimal places, again for convenience. So these are my x coordinates of my maximum and minimum points, and it asks us in our exam questions quite often that it wants the full coordinate. Now if we have x coordinates, this guy and this guy, typically we have a way of finding their corresponding y coordinates, and that is our original function, this guy here. Okay, and if we sub each of these x coordinates back in to here, so everywhere I see x, I'm going to put 1.097. That will give me the corresponding y value for this point here, and it's going to be a negative y value. And then if I put in minus 2.431 everywhere I see x, it's going to give me the corresponding y value for the maximum point. Okay, and that's going to be a positive y value. We can see that there. It's above the origin, so it's going to be a positive y value. And that's typically what they ask of us in our questions. I think beyond this, I'm going to move on to the calculus question that came up in your mocks and just go through that briefly and see how we get on there. Okay, so this is the question from your mock paper from this year that has the calculus question on it. Typically what we do see with calculus is that it will come up in paper 1, which it has here. It's typically seen in long questions. It's kind of mixed in with our functions, and it can also be seen in short question form, and I don't believe it was on this particular paper, but it came up in our long question here. So the first part of this has all got to do with our functions, and I can by all means make a separate video on that if needs be. So we went through this question. It was talking about a radiator company making radiators. It gave us a function for the cost of making those radiators. It gave us a function for the revenue that they could generate, and then it asked us about profit. So this is kind of where we came into our calculus. So next up it said show that the profit function can be written as p of x is equal to minus 0.5x squared plus 135x minus 95. And that again is just based on functions. It's just about, we found the profit here for 10 of them. And it's about subbing 10 in and seeing if we get the same results and subbing 0 in and finding those different points. There's also other ways we could find it, but that's probably our primary route there. And now part E, it says find p prime x. Okay, the first derivative of p of x to find the number of radiators that will maximize NRG's profits. All right, so we know that p of x, the original function here, is minus 0.5x squared plus 135x minus 95. So let's differentiate that. Let's find its derivative. So that's going to be denoted as p prime x or p dash x, and that means that we're differentiating here in relation to x. So if it has an x, we're interested in it. Minus 0.5x squared, we bring down our 2 times minus 0.5 becomes minus 1x, and we reduce our power by 1, so that's just to the power of 1 now. 135x, we bring down our power, which is 1, and that becomes 1 times 135 is just 135, and then x to the power of 0 is just 1, so we can kind of do away with that. And then we have our 95, our minus 95, and that doesn't have any x's, so we're not interested in it. Okay, so we have found the first derivative, and now we're looking to figure out what number of radiators will maximize NRG's profit. So that's kind of like part 1 to the question, and now we're looking to maximize. Maximize means the maximum value that they could attain, or the maximum profits. So we're looking for a maximum point, and we know that at a maximum or a minimum point, the rate of change will be 0, because what we found when we differentiated was the rate of change of the profits. All right, and we know that at the maximum amount of profits, it's not going to change. It's not going to go any higher because we're at the maximum. And we also haven't started decreasing in profits just yet because we're just sitting there for that split second at the maximum amount. If we were to think about it as a curve, profits increase and increasing, then they reach their maximum, and then profits start to decrease because their cost of production might increase for whatever reason it might be. So at the moment, we're just evaluating that maximum point right there. Okay. And now let's just see what x value we get here. We get that minus 1x plus 135 is equal to 0. Let's try solve this for x. We get minus 1x is equal to minus 135. All right. And then we get x is equal to 135. So that means that if energy produced 135 radiators, that is the maximum amount of profits they can attain in terms of the balance between their cost of production and the balance between how much they're charging to customers for the radiators. And then the final part to this question here just says find the maximum profit of producing the number of radiators in part E. So that's about taking your value of 135 radiators and placing it back into your original function. It would look something like this: minus 0.5 times 135 plus 135 times 135, or 135 squared, minus 95. And again, that is for finding profit, P of X. All right, when we carry out these calculations, so we have 135 squared gives us 18,225 times minus a half, or minus 0.5. That leaves us with minus 9,112.5 plus our 18,225 for 135 times 135 minus 95. And when we carry out all of those calculations, we get that P of X is equal to 9,017.50, and that is euro. So that's the maximum profit that they can attain from selling 135 radiators, which is also the maximum profit that they can make altogether. Okay, finally, just an overview. Calculus, differentiation, same thing. All that it has to do with is the rate of change at a given point. If we have a straight line, the rate of change is the same anywhere on the line. In addition to that, if we just had a point, just a single point, it doesn't have a rate of change because it's not going anywhere. That point there is fixed, okay? So it doesn't have a rate of change. All right, so that is that. The difficulty rises when we have a curve. So we're looking for the rate of change at a given point. How we find that is we're differentiating whatever function is given to us to represent that curve. When we differentiate it or find its derivative, the new function that we have is the function that represents its rate of change or its slope at a given instant. Maximum and minimum points have a rate of change of 0. They're not going anywhere. They're not increasing, and they're also not decreasing. And then when it comes into our real life questions in terms of exam papers, it's typically mixed with functions, but it can honestly come up anywhere. And it will also come up at times in short questions. Do out a few questions. If you want to send them on to me, do. If you'd like me to do another solution of a particular paper or a particular question from the book, let me know. Just drop me an email, and we'll work through this, and I'll try to pick a different topic and put up a different video that hopefully some of you might find useful.